Now, today's session is under our EDGE series, which says connecting campuses and enhancing employability. Here, we talk about new technologies that help us build new skill sets. Data science and analytics are flourishing fields at present. Unfortunately, there is a huge gap between demand and supply of competent workforce in the Indian job market. With this context, JMA brought this a session on how to build your career in data analytics. And for delivering the session, we have Mr. Satish Agarwal with us, who has more than a decade of experience with GE and Tata Steel, and currently he's working as a principal data scientist for a fine. He's also an active member of JMA managing team. I would like to welcome Satish sir on the floor and hand over the session to him.
Thank you, Asmita, and very warm welcome to all the people over here online present. So, I will just start briefly with my journey, how I moved to data science, and then I will let you know like what are the things we should follow if you are like really interested to move to data science. There are a lot of myths in the market that you have to like do PhD or you need to have mathematics, very strong maths is required. So I will clear your doubts, and at the end we can take few questions. Whatever doubts you have, I will try to clear it. So I will let you know, like I have started my journey as a software design engineer a decade back. I have around 13 years of experience, and I worked for around 4.5 years as a software developer. I worked on C, C++, and .NET, and then I moved to data science without having any degree of data science. I did engineering, and then on the job I moved to data science, where I worked as a initially as a data scientist, where I used to work on R and different databases to extract the data and develop the model. And I did this around for like 2 years, where I was not deploying any model. I was just exploring the data and playing with the data. So it was like around 2015, I would say. So that time there was no trend of deploying the model. If we are able to extract any details from the data or any insights from the data, that is also like a wow factor for the customers. So that is how like I have begun my journey. And later on, then when the technology and the computing has came in, so more and more computing industries also started like the cloud computing and all, which make our compute resources very cost competitive, and we leverage more computing to run our extensive models, the complex models. So that is how then later on I started deploying the model as well. And then I followed, learned the complete stack of data science, starting from getting the requirements till the development and then the deployment, and finally handing it over to the customer with the very good UI where the customer can like see the graphs and insights, and as well as the predicted output from the models, from the different models. So let me share my screen now. So let me know if it is visible or not. So you guys have like, most of you must be heard about the chat GPT. So these are like the end products of AI or AI ML or data science, whatever. Like these are the buzzwords we use: AI, ML. All are altogether meant to be like say some or the other way similar things. So like in the industries, people has categorized data scientists and data analysts. So there are slightly a line of difference, but most of them do the similar kind of work. I will take you through that also, what is the difference and all. So these are like the end products which has been developed by the data science world, like the Amazon Alexa. So this is also like the product of AIML. Then there are a lot of box of products from the Google. Everywhere your artificial intelligence or the data science or machine learning, whatever you say, is being used. Whether it is a YouTube, it recommends you the video based on your past videos you have seen. So the model is already there, which tells you based on your past browsing history. Gmail is also having your machine learning, which tells you when you compose a message, it gives you the words beforehand based on the machine learning. So Google Map, then the map is also based on the machine learning. So most of the Google product is some or the other way is using the machine learning. The translation, language translation is based on machine learning. So most of our AI products, which end as an end user we are using, is using a deep learning and machine learnings. So every other products in the market is using deep learning, and there is a humongous trend going on, and there is a huge requirement also coming in for this kind of expertise and this kind of skills the people will having. Currently in the market, there are a lot of people, but the good quality people is very less, and who like having a good quality. There is a lot of demand for those kind of peoples. So if you see, like everyone everywhere is talking about data science these days, and it is to be honest, like it is being used in every institutions, every corner, every business functions, whether it's a procurement or marketing or finance or HR or operations, everywhere it is being used. So whether it's a legal, whether it's a healthcare, in every industry, the data science is being used because data nowadays is getting generated like anything, and to make good insight of those data, the industries are also ready to invest a huge amount to make business out of it. So the way the earlier the traditional business used to happen, and now the business is happening is totally different. The way the management looks into the problem, the way they want to solve is totally different. So everywhere there is a data where there is a rational logic, and based on that they want to take a decision and they move on. So this is a market forecast by some of the research companies. This is from Precedence Research. So they are saying that the artificial intelligence market size will be very going to be exponentially high by 2030, which will be around like 1,500 or around $1,600 in 2030. So every year there is a, if you see, there will be growth, and the CAGR is around 38%, which is very high. So this shows like the trend for the data scientists will go on, and there is a huge requirement will be coming in the coming year as well for the data scientists. So if anybody is like planning to move to data science, there it's the right time to get into this. And if you're getting an opportunity to get onto this on job, then it is nothing good like it is the best thing I would say if you get any opportunity on job. Otherwise, you have to look for the other options, other avenues, like getting into some course from renowned institutes and getting the certificate, and then adding that certificate to move or switch your career to data science. So these are the options generally people avail to move to data science. But the on-job opportunities, so the market size of data science platform is expected to reach $178 billion by 2025. So this is also given by one of the research company. But I just want to like let you know, guys, what is like the hype in the market and what is the fact, I would say. So if you see, like hype is deep learning is like 80% people say like deep learning is being used or we are working on the deep learning, and like around 50% the machine learning, and around SQL and statistics like 20%. So it is the other way around. In industry, deep learning is around 20%, machine learning is 40 to 50, and SQL and statistics is used 80%. So this is like the most important skills as an individual you should know. If you don't know SQL, then you can't do anything in data science world, because you have to play with data, you have to extract data, you have to explore data. Everything is done on data. So like eat, sleep, and dream with data. So you must have to know SQL to work as a data science guy. And but the hype in the market is shown like deep learning is everything. But to be honest, like deep learning is used not in every industry. It is used mostly by the core tech industries like Google, Amazon, and all. And other industries depends on like the amount of data. Mostly LLM models like the large language models and all, or the translation models. These models use deep learning. But if you are going to solve the industry problems and the data quality is not so good or not in a high amount or a high volume, then you will not able to use deep learning. Either you have to go with machine learning or the statistical modeling. So that is how the solution is. And if you see like the data scientist job expectation, most of the data science is in machine learning only, and in deep learning it is like 20% what I said. But actually, when you go on the ground, it is not like this. The machine learning is also like machine learning, and deep learning is actually 10%. Maintenance is there, the model maintenance you have to do, feature engineering, data exploration. So all this comes in data exploration, this 40%. And understanding the problem is the biggest thing we should do whenever we are solving any problem. So this is the real scenario, real picture, and this is like from the outside industry, people think that if I get into the data science skills and the job, I will be all the time developing the model. But that is not correct actually. I will take you through this chart. So this is like presented by the Google, and it is known as a hidden technical depth in machine learning system. It was presented in 2015 in one of the conference. So if you see, these are the like overall, you can say the system while developing a single model or data science AI model. So if you see the ML code part showing in the red, this is like the small part as a data scientist people do, but there are a lot of other works which we need to do to make a single model to work completely, like configuration. So configuring the parameters and all, then the data collection, which is extensive thing. So it is not only done by data scientists, but data scientist is not always in every company is like his role will be within the ML code. So most of the data scientists have to work on feature extraction, data collection, validation or verification of the data, then finding the machine learning resource, which resource to be used, what infrastructure has to be there, how the model will be monitored, how the data will be monitored. So overall scenario will come, then the role of the algorithm part will be, I say, around 20%, and 80% of the time of the data scientist goes on all these other activities. If you're working on cloud, you have to make sure that whether you want to, suppose if you're working in Azure cloud, you need to figure it out whether you want to use Azure ML Studio, or you want to use Databricks, or you want to go with Jupyter Notebook. So there are different options and the cost is different. So you need to understand like what has to be used for what purpose and what would be the costing of it based on that. So these are the different things. So the team of people works and then they identify. So some of the things are like in within the team are distributed to different people. So that is I wanted to convey from this particular picture that data scientist is not always like developing a model. So moving to the next. So like we always see this as a like there are a lot of opportunities and we can do a lot of things in the data science world. We can develop models and we can give a accuracy, but there are a lot of different kind of requirements. Like there is a descriptive analytics, there is a predictive analytics, there is a diagnostic analytics, then there is a prescriptive analytics. So descriptive is basically like exploring the data. Once you explore the data, then you get insights from the data, or maybe you find some bugs in the data. So most of the time the industry data, it's like my practical experience, I'm saying we used to find lots of bugs in the data, because if I am working as a data scientist, my role is not to save the data in any database or any cloud. So the other guy who's working with the data as a data engineer, he's just pushing the data unknowingly, like whether the correct data is going or not. If there is no data governance process in the system, then it happens mostly. And like as our systems are maturing, so now the data governance role is also coming in. So in last 5 years, the data governance role is very less in any industry. So once the data engineer pulls the data, and as a data scientist, when you go and fetch the data, you find that there are a lot of bugs. Again, it goes to data engineer, and the data engineer has to fix those bugs, and again the data starts getting stored. So the earlier the historical data we can't bring in back, right? So so that is the reason. Then again, you have to wait for 6 months or 3 months to get the new data stored, and again you have to validate after 3 months or 6 months based on the volume of the data you require for your modeling. And then there is no fixed rule that this number of sample size is enough to make any model. So it depends on case to case basis and the veracity of the data, like the variance in the data, how much variance is there. So based on all those things, you can decide like whether how much sample of data is required for the modeling. So if anybody says like, okay, 50 records is enough or 100 records is enough, then it is. I don't know how the people say that. I have heard many times, but practically, like experience from the field, I'm saying it depends on the variance in the data. If suppose I'm having a 1 lakh records and there is no variance, then that record doesn't matter to me, like whether it's a single record or 1 lakh records. So there's a lot of things matter a lot. And I was saying like there is no only data scientist role. There are a lot of different roles, but all once get into the job, then they get into the different roles based on their interests and based on the requirement in the company. So there are like data scientists, data analysts. So data scientist mostly works on model development and all, and data analyst mostly works on the BA part where they try to generate the insights from the data as a business intelligence guy. So that is how I differentiate these two positions. Then there is a machine learning specialist who mostly works on the machine learning model and deployment of it. Then there is a business intelligence developer, BI developer, data engineer, data architect, infrastructure architect, statistician. So these are few. There are more than this. There are DevOps engineer, which is required nowadays in every industry wherever there is a cloud. And what I know is like cloud is everywhere. So if you guys are like taking a call to move to data science or you are in data science, you must be knowing that cloud is one of the necessary skills for the people in the data science world. Without cloud skills, it is like tough to survive because every computing nowadays, every industry is moving it to cloud, and cloud skills is like necessity nowadays. So if you see like the three language and tools you must know is Python, SQL, and cloud. So Python is like bread and butter if you're in the data science world. If you don't know data, like anything regarding your machine learning algorithms like random forest or anything, but if you know Python, you can play with data and you can make a lot of things. You can make a data frame, you can clean the data, and you can do all those things, and you can get the data ready. And then fitting a different models is like just a plug and play nowadays. You have a auto tools also for that, like a PyCaret and all. So based on that, you can easily build different models in a fraction of a second just by passing the right data with your like the x and y, and then you can come to know like, yeah, right, this is my model which is predicting my y, and these are my dependent features, and based on that I am getting my y. So Python is very important, I would say. In the academics, R is preferred, but in the industry, Python is preferred. So if you are planning to move to data science, you have to learn Python to make a good progress in your job and make a faster climb, I would say. And SQL is very, very, very important because you have to play with data. So many times you have to extract from the SQL database or the Oracle database, or sometimes you have to extract the data from different sources. So it depends, but SQL is very much necessary to extract for extracting the data, and SQL is very simple as well to learn as so it's not a big deal. And cloud, either Azure or AWS or Google, so any one of the cloud you must know to work with, because cloud is required everywhere nowadays. And without cloud, like it is, I would say, running a model in a local machine will not work, because most of the time our machines are 16 GB RAM, and our models needs much more computing than that. So in those cases you will get stuck. And like if you are planning to move to data science, like want to work on model development, then you must, these are the like basic core things required. On top of this, like I told in my previous slide, you want to be data scientist. If you want to be data scientist, then you need to know the all the statistics, and on top of statistics you need to understand the working of each different algorithms like regression or random forest or XGBoost or your neural networks. So all the different models, you need to understand the working of those algorithms. Then only you will be able to work as a data scientist. So depends like which. like which position you want to work. If you want to work as a data engineer, then you have to mostly focus on SQL and Python. You need not be required to know about the different algorithms like random forest or XGBoost or decision tree. So it's not required really. If you want to work as a data scientist, then or as a machine learning specialist, then it is required. So it depends on like what position you want to work. So based on that, you have to take a call. And like there are lots of courses also available in the market. So if you want to like switch from some other suppose you have done a mechanical engineering and you have worked for 2 years or 1 year and you want to switch. So my suggestion, if you don't know anything about data science, then take a structured course from some good institute who provides at a sorry, at a reasonable price, and then go for it for a 6 months or a 1 year course, and then switch. So it will be easy. But still, like I saying is easy, but doing is not easy, because and lot of myths are there, like you need to know mathematics very well. So there are two kinds of data scientists as well, I would say. One is a research data scientist and another is a applied data scientist. So research data scientist needs to know mathematics very well, because they will be working on developing the models, the algorithms. I mean to say, like working on kind of random forest algorithms. So they will be working on bringing new algorithms or playing with the code of the algorithms as well, and they will be inventing new algorithms. And the other is applied data scientists who use these algorithms as an end result, just plug their data into these different algorithms and see how it is fitting the model and which model is giving the best result. So applied data scientists should be not required to know mathematics in 2D. And if you want to go for research, mathematics, and if you are doing PhD, that is value added for the kind of research oriented job. So these are the basically two domains in data science world, either the research or either the applied. So I am working as an applied data scientist, and I generally try to fit the different data to the model based on the requirement from the industry. I have worked on the manufacturing side. Now currently I'm working on the marketing and sales front. So there are different use cases everywhere in different business domains. So there are a lot of use cases in finance, there are a lot of use cases in HR, there are a lot of use cases in procurement. So still like the battle is going on, and there are right now like chat gpt is there, now Google has bring bard. So a lot of this kind of tools are emerging in the market, and we never know like what AI can do. So recently, like your the tool, I forgetting the name, so they bring in to generate the images. So you can generate the image using that AI tool. You don't need to uh, create an image, or you don't have to design an image, or you don't need any artist to build your image. So on a fraction of seconds, you can get your image through AI tool. So that is the possibility we can see through the AI tool, and lot of like gap is there in the industry still. Like the young generation, I mean to say, like the engineering students who are like still working, they also like immediately try to fit the model. So they don't want to learn the basics. So that is the gap is like becoming bigger and bigger. So first, the important step is to, if you want to get into the data science as a model developer, then you have to understand the statistics, and the working of the algorithms is very, very important and a minimum bare requirement, so that you can start and build your knowledge on top of that. If you were just simply looking through YouTube or any videos and starting fitting the models and auto ML algorithms, then it will not solve the purpose. You will never be knowing how it is working, what is the inside. So it will be always a black box for you. Though now there are a lot of explainability and interpretability algorithms are also coming into the market, which will explain the working of this black box, like a SHAP and mimic explainers are there, which will help you to explain the how the model is in. like developed, and which are the important factors or the features being used by the model. So those things are like getting and emerging and like coming into the market, and a lot of things are coming on a daily basis. And anybody who is coming to this field has to always keep themselves updated and has to learn on a daily basis what the new technology is coming into the market. So it is not like if you are completing engineering and getting into the data science, now you don't have to study anymore. So you have to study in this particular profile on a daily basis. So if you are not keeping up to date yourself, then you will be like slowly out of the market and out of the like what is in the tech stack world is going on. So it is not easy to say. So I am done now. So any questions, I would be happy to take.
There is a question in the chat box by Mr. Niranjan Raut. How much maths knowledge is good for applied data scientists?
So maths knowledge is required. So whatever like you have done in your 10, 12, so algebra and calculus is the bare minimum thing is required. But you don't need to know the inside of the algorithm, like the theorem of it. So for applied data scientists, I would say like it again depends on the individual's interest, how deeply you want to understand the working of the algorithm. So if you just want to understand like how my particular say a random forest is working, if I'm passing a data, what the algorithm is doing with my data. So for those working, you don't need to know the maths much. If you want to know like how it is taking my data and then how it is interpreting and then how finally it is giving me the output, for that purpose, you need to understand the maths much better. But if you just want to know the working of the model, then maths is okay. So for applied, you don't have to get too much deeper into it. So
That
Ashish is saying,
yeah.
I'm taking the next question. Ashish Kumar Mishra is saying, please suggest some good online courses for data analyst. So for data analyst, I would say there are a lot of courses in the market. Again, like I haven't done research recently on this, like which are the good courses. So like one of the you can see all the IITs are giving similar kind of courses. So you can look for those. So depends on like your background also, Ashish, if you are engineering graduate or MBA graduate. So from where you are starting your career after 5 years or just starting your career. So a lot of things depend on an individual as well. So there is no one rule fit for everyone. So based on case to case, we need to understand. I can't say like, yeah, you go for this course, it will be best. Hope you understand it. So Ravindra, I already explained like there is a very minimum line of difference between a business analyst or data analyst. Both are same according to me and data scientist. So data scientist mostly works on the model development and all, and business analyst or data analyst works on exploring the data and like building a different kind of reports, the business intelligence reports for the end user, the customers, where they want to see the data in different charts, which will give better insights to them. Niranjan Roth is asking, as an organization starting on data analytics journey, would you suggest hiring data engineers, scientists on payroll or outsourcing this? So again, it depends on organization to organization. So suppose if it's a big organization uh, and they want to start on data analytics journey, so if you want to outsource, you can do that, but internally also you have one or two people at least who understands the data science so that they can drive it and they can monitor the things what the outsourced resources are doing. Otherwise, it will be tough. 2 to 3 resources required internally bare minimum if you don't want to like have it in your payroll. Hope it answered your question, Niranjan. If you have any point on this, you can question back or you can ask in the chat it on the mic itself. Avdesh Shukla is asking like which tool will be better for the process parameter optimization and decision making. So this also like of this I have worked in process organization as well. Like my previous experience was with Tata Steel. I worked for Tata Steel around 8 years, and I worked in manufacturing for steel making and iron making, both the plants, both the areas I would say. And it is not a fixed rule that for process parameter optimization or decision making you have to go for particular tools. So I can categorize in two ways what is coming to my mind. For process parameters, we use Python only, like storing the data and playing with the data and coming up with any model. So, and we have used Tableau as well. If suppose just we have to explore the data and understand or bring it into some chart. And decision making again, the Python only. And there was a optimization also for we use different tools, the solvers and all, to come up with the optimized solution for any kind of problem where we need to get the optimized solution based on different constraints and the bare minimum resources we have to use. Ravindra is asking skill required for business analyst. So Python and SQL is must, Ravindra, to get into business analyst role. And on top of that, you have to have like Power BI or Tableau. So this three thing is bare minimum required if you want to get into data analyst or business analyst role. What about prediction decision making? So of this, can you come on mic and explain a little bit like what you mean by prediction decision making? I'm not able to understand.
Hello,
Yeah, this.
I'm audible.
Yes,
Yeah,
yes.
yeah. So this I want to just know. We want to do some prediction analysis. Yeah, to prediction decision. Suppose we have the excellent data system and we want to do some prediction at what time our equipment or process will fail, our product will fail. But once alarm, yeah, you can say decision will pop up from the system, yeah, software, so that we can alert and prevent these losses. That was my question.
Okay, so what I understood, I will just repeat your question. So you are saying system kind of anomaly detection. So if any failure is happening in your process, you should get a kind of alert or alarm beforehand so that you can take a proactive action to get out of that failure, right?
Correct, correct.
So that will help you to take the decision whether you have to fix it right now or you have to fix it later and all those things. So
Yeah, yeah.
again, like for anomaly detection, also we have used Python itself for model development and deployment and everything. Again, it depends on case to case basis. If you have a something critical and you need the alert to be generated for what I understand for the process industry, it should be like within a fraction of minute maximum. I would say fraction of seconds. You should know after the there is some kind of anomalies happening. You should know at least within a minute that yeah, there is going to be problem in this particular machine or this particular area in next 20-30 minutes, so that the shop floor guys can take the action on it. So, like we have deployed in the end user machine, like the edge computing we say generally in this world. So we have taken the process PC where we have deployed it, and the in the process machine itself, the data is also coming in. So where the data is coming immediately when the data comes in from the PLC and all and gets stored in the level 2 machines, we have deployed our model over there. We have trained the model in different machines, and after developing, we have deployed the Python model over there, which will take the data from the for that particular machine itself and give the output, and then that output is further getting consumed in some front end machine from where the user can see what action is to be taken, whether some action is required, some decision needs to be taken. So that is how one of the example I remember I have done in Tata Steel. So that helps the users to take a very fast decision. And if you have a time, suppose if you in your process there is no but nothing is happening, then you can like take single prediction is required for a day. So in that you can uh, deploy the model anywhere and that should work. So any process industry, yeah, Tata Steel, I am saying in Tata Steel, I have deployed myself this kind of model, two, three models are running, which I have deployed, and my other colleagues has also developed this kind of models. So many models are there in Tata Steel, which is giving real time kind of output. So you are from which organization of this?
I am from Tata BlueScope Steel.
Okay, okay. Yeah, so it is there. I think you can, if you are able to connect to Tata Steel guys, then the automation team, they can help you to let you know.
Any more questions from the participants?
And I would like to say one more point, as there is no questions right now. So there is kind of no nothing like that. The person should have this kind of skills, then only he can switch or move or can start career in data science. If you have an interest, you can definitely move to it. Depends like how you are getting the opportunity. If you are getting the opportunity on job, then it is very easy. Otherwise, you have to get on some course, and after the course also, it is not like immediately you will get into data science. Sometimes if you are getting a course which is providing you the placement, then it is good to go. Otherwise, many a times people has to struggle to switch to data science from their particular regular job, because suppose if I worked in 10 years in industry as a mechanical engineer and I want to switch to data science after 10 years, then again I have to start from zero, because the earlier experience is not going to be count in the data science domain. So those are the some challenges. So anybody like planning to switch or taking a call, so take those decisions judiciously, because later on the frustration comes in.
Thanks. Thank you, sir. I think there are no more questions. So we are at the end of the session. So before we conclude, I would like to share that JMA is offering a course with in collaboration with ISI, Indian Statistical Institute. This is a comprehensive course in business analytics. It is completely online, and the certification will be given by ISI. So if you're interested, you can reach out to us later on, and we will share the details. And these classes are set to start in March 2023. And before we conclude again, please share your feedback so that on this session, and so that we can plan such sessions in the future as well. Thank you so much, Satish sir, for sharing your expertise on the JMA platform. And we look forward to more such sessions in future. And thank you to all the participants for being interactive and joining the session today. Do share your feedback, and we hope to see you in future events of JMA. Thank you. Have a good evening.
Thank you all. Have a nice day.